Hello and welcome to another video. Today I think we have the fifth problem in a row where it's an easy problem of the day, so this is probably going to be like 10 LeetCode hards after this. And we're going to be doing a count of matches in a tournament. And this is pretty straightforward if you've ever seen a tournament bracket like an NBA bracket or anything. So you're given an integer n, the number of teams in a tournament, that has strange rules. If the number of teams is even, each team gets paired with another team. A total of n over 2 matches gets played, and n over 2 teams advance. If the teams is odd, one team randomly advances in the tournament, the rest get paired. And so a total of n minus 1 over 2 matches are played. And n minus 1 over 2 to the 1 teams, or over 2 plus 1 teams advance the next round. Return the number of matches in the tournament until a winner is decided. So this second one is kind of like if a team gets a bye, right? So if you have like 3 teams, 2 teams will play, and another team will just automatically advance to play the winner. So it'll be something like this. So it'll be like 1 plays 2, and then 3 automatically advance and plays the winner of that. Okay, so there's 2 ways we could do this, and one of them is a pretty straightforward simulation of the matches. So we can just say, let's say our number here is, let's just pick up some big number. Let's say our number of teams like 85. We can say, okay, well, for every single stage of the tournament, how many matches will there be, right? So for every single stage, there will always be n divided by 2 matches. And this is a floor divide, right? So there will be 42 matches in the first stage because there's 85 teams. So one team automatically advances because it's odd. And the other teams have to play each other. So in this first stage, there will be 42 matches. And how many teams will be left over? So we're going to have some like result. And in stage 1, we will have 42 matches. So let's actually write this down. And let's write down everything just to make it a little better. So let's write down 85 teams. And let's do it like this. So, so stage 1, 42 matches. And how many teams advance? So 42 teams will advance, right? Because out of every match between 2 teams, 1 team advances. And then also, if there's an odd number, then 1 team didn't have to play. So in this case, there will be 43 matches, 43 teams advance. And so let's just fill this out until we have a winner, and then we can add all this up together. So we have 43 teams advance. So in stage 2, once again, because it's an odd number, we will floor divide by 2. So we will have 21 matches, right? And then how many teams will advance? So we had 43 teams, 21 matches. That means 21 teams advance plus the 1 team that had the bye, quote unquote, right? So this will be 22 teams advance. Now we have 22 teams left over at stage 3. So there will be 11 matches because we have an even number, and 11 teams advance because since it's even, every team gets to play and the winner of every single one advances. Then we keep going. So here we have 11 teams, so there will be 5 matches. So 5 teams will advance from those matches, and 1 team will advance because it had the bye. So 6 teams advance. And then we have the next one. So we had 6 teams, so there will be 3 matches, and 3 teams advance. No one gets to skip one. Then, now that we have 3 teams left over, there will be 1 match, and 2 teams advance. Because 1 team gets to bye again, right? If there's 3 teams, 2 teams will play each other, and one of them gets to just go through for free. Now that there's 2 teams left over, there will be 1 match, and 1 team wins. And so we're asked to return the number of matches total, so it's just going to be the sum of all of this. So it's going to be 42 plus 21 plus 11 plus 5 plus 3 plus 1 plus 1. And that's going to be, we can just figure this out, right? So 63, 74, 79, 82, 84. So we have 84 matches, right? And we can easily simulate this. So we can easily simulate this. We can just figure out at each stage how many teams do we have. If we have an odd number, or we don't really care if it's an odd number or not. So it's basically going to be the number of matches for a stage equals number of teams floor divide by 2, right? So if it's odd, there will be, if there's like 81 teams, there will be 40 matches. If there's 80 teams, there will be 40 matches. And then the number of teams that advance will be number of teams. And now this is the ceiling divided by 2. So ceiling divide by 2. Right? So for example, if there are 81 teams, you will divide by 2, you'll get 40.5, and you will round up. Because for 81 teams, there will be 40 matches. The winner of those 40 moves on, and then one team didn't have to play, so it'll move on. And this is basically, you do this until you have a winner. So you just keep adding matches until you have a winner, and this is going to give you, so we're essentially taking our matches and we're dividing by 2 each time, so we get logarithmic time complexity. Now you may notice that when you try a bunch of these examples, you notice that the number of matches is very close to the number of teams, right? Because essentially you're doing, like, for 85, your matches is like 42 plus 21 plus, you're kind of dividing by 2, and you're roughly getting something close. And that's because there is an observation we can make. So we're not going to code up this because there's not much to code up, but there's an observation we can make. This is the second way to do it. So this would be part 1, right? We just do the simulation until there's a winner. The second way is, notice for a match, one team wins and one team loses. So if in every single match a team loses, and there are 85 teams, in order for 84 teams to lose, we would have to have 84 matches. And that is an observation you can make. And from there, you can just know that the number of matches will always be teams minus 1. So that if you want to code that, so you can literally just return n minus 1. And that will always be true because for every single match, one team loses. So you just need n minus 1 teams to lose. So that would be the other way to do it. And now we can code up the simulation way because obviously not much to code up for this one. Okay, so we're going to need matches. So we'll say that's 0. And then we will also, that's all we need. So we're essentially going to simulate these stages of a tournament. So we'll say while n is greater than 1, while there isn't a winner, let's keep simulating matches. So how many matches do we have at each stage? It's just going to be the number of players left, floor divided by 2. Right, so if there's like 81 players, you'll have 40 matches and one person will get a bye. At most, one person can get a bye, so there's that one. And if there's an even number, then every person will play each person, so the matches will be n over 2. Now, n is going to be n divided by 2, but this time it's going to be the ceiling of that. And that's because, for example, if you have that same 81 people, you'll have 40 matches, and then 40 people will get eliminated, so you'll have 41 left. One person gets a free pass. So that's why it's a ceiling. And then you just return matches. Try that. And you see it works. And so funnily enough, when I was doing this a bunch, if I actually tried the other solution, I was actually getting that somehow was slower than this. I don't know if it's consistent, but yeah, you see it's like, we have a log n solution versus I guess we could talk about it real quick as well. So this first solution is going to be log n, because when you take a number and you keep dividing it by 2, that's going to be logarithmic because you're basically getting rid of a bit at a time. So it's like if 2 to the n equals a number, that's exponential. And if you keep dividing by 2 to get an answer, then that's logarithmic. So time is going to be logarithmic for this simulation. And space is O of 1. Obviously for this, it's O of 1, O of 1. But yeah, just kind of funny. I thought I'd share this thing that, like, for these test cases, I wouldn't be super concerned with the numbers it gives you because they're not super accurate. So obviously, if it gives you like 6,000 ms, then, it's not going to take like 200. But for these small things, like, it's just all over the place. Just click a bunch and it'll get a bunch of different stuff. So. Yeah, that's going to be all for this one. Hopefully you enjoyed this one, and can't wait till we get like 10 LeetCode hards coming up for the holidays. So yeah, if you did like it, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.